In this video, we're going to talk about the second part of 10.3, which has to do with equations that can be written in quadratic form. So an equation in quadratic form is of the form a times something squared plus b times something plus c equals 0. And we can solve it using the quadratic methods that we've learned previously, either factoring, completing the square, or quadratic formula. But we use a process of substitution. So for example, I want you to consider this equation where it's x to the fourth minus 13x squared plus 36. Now if I think it's an equation that can be written in quadratic form, I first look at this piece here and I say, okay, if this is my x, right, or my new piece, then is this equal to that same thing squared? And in this case it is, because this is x squared, let me rewrite that, x squared minus 13 times x squared plus 36 equals 0. So I say for myself, we often I use the letter u. You don't have to use u, you could use a different letter, but you get the idea. Is we're going to make a substitution and we're going to say everywhere where I see an x squared, I'm going to put a u. So then what I end up with is a u squared minus 13u plus 36, and that equals 0. Okay? Now I can solve this just like a quadratic equation, where I can say, okay, well, a is equal to 1. I'm going to use the quadratic formula. B is equal to negative 13. C is equal to 36. I'm going to use quadratic formula, but if you see another method that you could use, please by all means go ahead and do that. Okay? So what we say is u equals negative b plus or minus the radical of b squared, so negative 13 squared, minus 4 times 1 times 36. And this is all divided by 2 times 1. Okay? So remember, when we simplify, we're going to get 13 plus or minus the square root of 13 squared is 169, and 4 times 36 is 144. So we're going to subtract 144. I realize I forgot the other half of my parenthesis there. And this is all over 2. So that is equal to 13 plus or minus the square root of, let's see, 25 all over 2. So that gives us 13 plus or minus 5 over 2. So two different situations here. 13 plus 5 divided by 2, so that becomes 18 divided by 2, which is 9. 13 minus 5 divided by 2, so 13 minus 5 is 8. 8 divided by 2 is 4. So I have two solutions. U equals 9, U equals 4. Now I'm not done yet, because these are my U values. I have to then plug these back in order to get my x values, because remember the problem was in terms of x. So I just plug it back into this equation. So I have 9 equals x squared. Well, we know that we can solve this by taking the plus or minus square root of both sides. So now I'm going to rewrite it with my x part first. X equals plus or minus the square root of 9, which is 3. So there are two solutions right there. X equals 3 and x equals negative 3. Similarly, I'll say 4 is equal to x squared. So now I have to take the plus or minus square root of both sides. It just happens to be that these are both perfect square numbers that we came up with here. Won't always be the case. So I have x equals plus or minus 2. So I end up with actually 4 answers for this problem. Positive 3, negative 3, positive 2, and negative 2. Okay? Let's take a look at another one. Similarly here, we are going to come up with a u substitution. And again, I look at this middle piece because I say, okay, well, if this is my u equals x plus 4, then this has to be u squared, which it is. So this becomes u squared minus 7u plus 8, and that equals 0. Okay? And so now we're going to go ahead and solve. Again, I'm going to use the quadratic formula just because I know that it's pretty straightforward for me and it works out nice enough. Okay, So u equals negative 7 plus or minus the square root of negative 7 squared minus 4 times 1 times 8, all divided by 2 times 1. So this is 7 plus or minus. I'm going to skip a step here just because I think you can hang with me. This becomes 49, and then 4 times 1 times 8, that becomes 32. So 49 minus 32 is 17, all over 2. So these are my two answers right now. This is u. And remember, one of them is 7 plus square root 17 over 2, and one of them is 7 minus square root 17 over 2. Okay, now I need to plug that back in and I can figure out what my x values are. Okay, so now I say, well, 7 plus square root 17 over 2 equals x plus 4. So I have to subtract 4 from both sides. Now this is really thinking of this as 7 over 2 plus square root 17 over 2, and then I'm going to subtract 4 from that, so that's minus 8 over 2. Remember, I'm writing it with common denominator. So 7 over 2 minus 8 over 2, those are the pieces that can go together. So I actually get x equals negative 1 over 2 plus 17 over 2, or I could write it as, square root 17. Negative 1 plus square root 17 all over 2. Similarly, I'm going to do the same thing, but as you're going to see here, as you can see here, the only thing that's going to change is this symbol here. I don't know why I wrote it as plus again. This is supposed to be minus. When I subtract 4, I get 7 over 2 minus square root 17 over 2, and then minus 8 over 2, just like we did before. So I have x equals negative 1 minus the square root of 17 all over 2. So if you put these two together, you really would have negative 1 plus or minus the square root of 17 all over 2. Okay? So that's how we work with this type of equation that's in quadratic. It's in quadratic form. Just as a side note, it says if at any point you square, you raise to an even power, so square both sides of the equation, or if you are going to raise both sides of the equation to the 4th power or something like that, you need to make sure that you double check your answers. In this case we didn't, though. We took square roots, but we didn't square or raise to a 4th power or any other even power. Okay? That's all for this one. We'll see you in the next video.